For scenario A, a cart moves to the right with a constant speed of 2 meters per second for 3 seconds. The cart then does not move for 3 seconds and then moves left back to where it started with a constant speed of 3 meters per second for 4 seconds. All right, I'm going to start by labeling my x-axis on both graphs. This is showing the same motion, and so if it's showing me the same motion, my graphs should have the same x-axis because the same amount of time is passing. When I look at the amount of time in each of these, I've got 3 seconds, I've got 3 seconds, and 4 seconds. Adding that together, I get 10. So I'm going to make the x-axis of each of my graphs time in seconds, and they should both go up to 10. Now let's look at some speeds. So I've got 2 meters per second, does not move, and then 3 meters per second. One important thing to note is that that 3 meters per second is back to where it started. So really, we have a negative 3 meters per second. So I'm going to label the velocity axis, or the y-axis, of my graph in meters per second. And because I have positive and negative speeds, I'm going to put my 0 directly in the center. I am now going to go up by 1s. These are all my negative values below 0, and count up in positive values above 0. Now I can use my red pen, and for the first 3 seconds, I'm traveling at 2 meters a second. So here's 2, and that happens for 3 seconds. I'll draw my flat line. For the next 3 seconds, I do not move, meaning my speed is 0. So at the 0 line for speed, from 3 until 6, I have a flat line showing no speed. Connect those with the dotted line. Okay, now for the last segment, I have 3 meters a second for 4 seconds towards the original position, meaning I'm at a negative velocity. So negative 3 for the last 4 seconds. And I will connect those. Okay. Now, when we're taking area underneath in order for us to calculate the distance we traveled, in this first segment, I'm going to go from the 0 line, or from the 0 on the y-axis, towards my data. So I've highlighted this area that I'm going to take the area of in order to calculate distance. So for this first segment, I have a height of 2 and a width of 3. So 2 times 3 gives me a total of 6 meters. This center segment, or letter B, if we label these out, letter B is flat on 0, meaning I don't travel any distance there. I can also understand that knowing that I do not move. So for B, the total distance I travel at B is 0 meters. For C, I'm going to take the area from the 0 to my data, just like I did before. This is the area I am calculating in order to know how far it is that I travel. So in this situation, I have a height of negative 3 times my width of 4, giving me negative 12 meters as my distance. Now, when I go over to my time on the left graph, I'm going to put position on my y-axis, and that's in meters. Now, as I start to look at my graph, I know that I travel 6, and then I travel 0, and then I travel 12 backwards. Okay? So for my position versus time graph, I'm traveling more distance backwards than I am forwards. Okay? And that's because the forward direction I've only got 6, the backwards direction I have got 12. So on this graph, I'm going to put my 0 axis in the center again. Now, I'm going to count up by and down by 3s. So negative 3, negative 6, negative 9, negative 12, negative 15, and the same up. Okay. Now using my red, I can start to graph. So I start at 0, 0. And in the first 3 seconds, I travel 6 meters. So I'll find 3 and I'll go up to 6. I've got my diagonal line. For the next 3 seconds, I don't move, meaning my position does not change. I have a flat line at 6 meters. Now, I travel 12 meters in the opposite direction. So that 12 meters at 10 seconds doesn't put me at negative 12 because 6 of those meters are above my 0 line. So if I want to take away 12, I need to travel a total distance of 12. After 10 seconds, my dot is at negative 6. The reason it's at negative 6 and not negative 12 is because I'm currently at positive 6. If I'm at positive 6 and I subtract 6, I get to 0. If I subtract 6 more for a total of 12, I get to negative 6. Now for this segment, I use a straight line to connect my 2 dots. You should use a ruler so yours is nice and straight. And that's your position versus time and velocity versus time graph for scenario A.